Hello class, this is Mr. Hart, and in this lesson we want to start talking about galaxies, okay, probably the largest object we can think of in our universe, which is really just a collection of smaller objects. But we want to start thinking about grouping things in the universe and how we classify them, talk about them, etc. Okay, so let's start talking about galaxies. So when you think about a galaxy, it's just a big collection of stars, okay? So our smallest unit, if you will, is a single star. So a star by itself we just call a star. There's no special grouping. But what if we have two stars? Okay. Well, we call a system of two stars a binary star. Okay. So a small grouping of stars is a binary star, and binary stars are really cool because they'll actually generally spin around each other, okay, in kind of a big spiral. And they're actually more common than you might think. A lot of solar systems have two stars in them, okay? And the hard thing about binary stars, though, is often it's hard for planets to exist around binary star systems because if you get too close to the spiral as they're going into each other or around each other, then you'll probably just get eaten up in the star as you're going. So binary stars generally don't have, lots of planets. But there are exceptions, of course. Here's a simulation of such a binary star system. So we have these two binary stars going around each other, and then we have a really small planet going around the outside. And you can see this kind of constant dance that they do, just spinning around one another. Okay. But binary stars are really cool. They're fun to think about, and if they get too close, they'll actually combine to become one really big star. Okay. So that's our first grouping, is binary star. Okay. Just another thing to think about that's kind of fun is if you're a fan of Star Wars, you probably have seen A New Hope, the very first Star Wars movie. And in that one, there is a double sunset because there's two stars. So Tatooine's part of a binary star system. Okay. Another fun thing to think about is if you had two suns, you could actually have multiple rainbows at the same time. So on Earth, you can only get about two rainbows at the same time. Sometimes a double rainbow is really rare, but you can. But with double sunsets, you can actually get up to, I think, to 7 rainbows or something crazy, theoretically. Okay, so if it rained on a planet in a binary star system, you could have many, many rainbows in the sky, which is kind of cool to think about. Okay, so we have binary star systems. Why don't we have tertiary, right? 3 stars or quaternary or any of these other star systems? Okay, why can't we have 5 stars in a star system? Okay, you can, but generally it's too unstable to have that many stars in the same system. So they usually just collapse and become one big star. Okay, so we automatically jump up. We have star, binary star, and then the next biggest grouping is what we call a star cluster. Okay, so a star cluster comes from grouping about 100 to 1,000 stars together, not in the same system, but just all around. And this is usually in the early stages of a galaxy forming. Okay, so if you have a bunch of stardust, hydrogen and helium essentially, that material will pull together because of gravity and start to group and form lots of stars. So star clusters are generally young. They're kind of baby stars in the star cluster. Okay, but you're starting to get lots of stars forming together, forming in kind of the same region, gathering the same material together. Okay. So if multiple star clusters start to form together, or star clusters just get older, then you can get into the galaxy range. Okay, so galaxies form when you have anywhere from a few million to as many as a billion stars in the same region. Okay, and in class I show a video where you can see the star clusters start to collide, and just like if you did a whirlpool in a swimming pool, if you've ever done that, where you just get everyone going in the same direction, you get this kind of nice whirlpool going on in the water. Galaxies do the same thing. If the star clusters start to hit and combine into each other, right, and just lots of stars start to hit, then you get kind of this motion occurring, this circular motion. And so that's why a lot of galaxies kind of spiral as they're going through. Okay, they kind of get this general direction that they form in. Okay, so that's our groupings of different sizes. So regular star, binary star, star cluster, or galaxy. Okay, so galaxies, the biggest. What are the different kinds of galaxies? Okay, so our next thing we want to discuss is different types. So we have spiral galaxies. That's the most common, or the one we think about the most. Okay, and they spin just like we were discussing because you get that motion as things are hitting into them. So they're generally younger galaxies because they're multiple star clusters that have hit into them. Okay, and they also generally tend to have a black hole in the center. We'll talk about that later on in another lesson. Okay, but so much mass is gathered at the center that a black hole forms there, and so spiral galaxies generally have a black hole at the center, which helps with that continual whirlpool motion. Okay, something that's also kind of fun and weird to think about is that the galaxy is not only spiraling, but it's also very flat. So if you looked at a galaxy from the side, you'd see that it's kind of a flat disk, which is interesting because you have that spinning motion, but it's not necessarily 2D. It is 3D motion, but that whirlpool motion also flattens out the disk itself. Kind of like if you had a pizza. You ever seen like an Italian pizza man spin the pizza around and it kind of flattens out as the dough spreads? Kind of the same idea with galaxies. If you get that spinning motion going on, it flattens out the disk. So spiral galaxies are spinning, but they're also flat. Not completely flat, but generally flatter. They're a flat disk. Okay? Mostly young stars because of the reasons we talked about. Okay? Another type of galaxy is elliptical galaxies. So elliptical galaxies either come from a kind of a spiral galaxy that's aged, so the motion is finally calmed down. Okay, so the stars are generally older, or maybe it was never big enough to form a spiral galaxy, so over time a lot of stuff has slowly gathered into a galaxy. But the point being is they're usually older stars. Okay, there's not spiral motion. It's usually older stars. One student I talked to once put it as, this is where stars retire. It's a retired galaxy. Okay, all these old stars. Okay, and you get kind of this more oval or egg shape because you don't have the flat disk. They just kind of slowly gather into the same spot, or the spiral and the flat disk kind of settles down, and so you get these elliptical galaxies. Okay, when you see them in the sky, they're kind of a reddish yellow color. And then for any other galaxy that we just don't really know how to talk about or describe, they're called irregular galaxy. Okay, so it just might have a weird shape because it didn't quite form the way we would expect. But those are the three types of galaxies. So spiral, elliptical, and then anything else we call irregular. Okay. All right. So what about our own Milky Way Galaxy? How would you describe that? Okay. Well, first of all, why is it called the Milky Way Galaxy? And funnily enough, it's called the Milky Way Galaxy because of how it looks. Okay. So if you were an ancient astronomer and you were looking at the sky, you could see this line of kind of brighter stars and what really looked just kind of like spilt milk in the sky. It was kind of a milky froth, and so that's why they call it the Milky Way. But what were they actually seeing? Okay, if you look at that milky froth, it's actually kind of this inside part of the galaxy. Okay, it also could also be kind of the outside part of the galaxy. Okay, so but either way, you're seeing kind of the insides of the Milky Way. Okay, the actual galaxy itself. But that froth they were seeing is just part of the Milky Way, and so that's why it's called the Milky Way Galaxy. That's what we named it after. Our own sun would be right about here, towards the edge of the Milky Way Galaxy. And here's the crazy part. The Milky Way Galaxy is 100,000 light years across. Okay, and we talked about light years, trillions of miles. And it's 3,000 light years thick. So even though it's kind of a flat disk, okay, it's still a really thick disk, right? So 1,000 years, 100,000 light years this way, and 3,000 light years this way. So it's a pretty thick disk, but compared to how wide it is pretty thin in this direction. Okay, so that's our Milky Way Galaxy, and it is a spiral galaxy, and it does have a black hole in the center. Okay, so there you go. Talked about a lot of terms in this lesson, but these are the ones you need to know. So binary star, grouping of two stars. We had star cluster, which is a larger grouping of stars, hundreds to 1,000. Then we had a galaxy, which is millions to billions of stars. Okay. Then we had the types of galaxies. So we had spiral galaxy, which has spiral arms. I didn't mention that specifically, but the outside of the galaxy is called the spiral arms. Younger, lots of movement, etc. Black hole in the center. We had elliptical galaxy, older, not as much movement. Okay. And then irregular galaxies that we can't really describe, or there's not really a good shape they have, etc. And then our own Milky Way galaxy, just remember that it is a spiral galaxy. Okay. And it's, of course, our galaxy. Okay, but there you go. Hopefully that makes sense. Let me know if you have any questions, and thank you for watching.